And what about time? Does nature change continuously, or does the world evolve in series of very tiny steps, acting more like a digital computer? The past 16 years have seen great progress on these questions. A theory with the strange name of loop quantum gravity predicts that space and time are indeed made of discrete pieces. This theory has deepened our understanding of puzzling phenomena having to do with black holes and the Big Bang. Was the Big Bang really the beginning of time? Whether the universe had always existed or whether it had a definite genesis. Einstein's general theory of relativity implies finiteness. An expanding universe must have begun at the Big Bang. The task has occupied theorists from Einstein onwards, but progress was almost zero until the mid 1980s. Physicists Stephen Hawking and Roger Penrose proved in the 1960s that time cannot extend back indefinitely. As you place cosmic history backward in time, the galaxies all come together to a single infinitesimal point. That is what our J.J. Raval he had spoken about, and even Pankaj Doshi, known as singularity, almost as if they were descending into a black hole. Each galaxy or its precursors is squeezed down to zero size. Quantities such as density, temperature, space, time, curvature become infinite. Due to high degree of homogeneity and isotropy, the universe exhibits on large scale. Singularity poses serious problem for cosmologists, that how that Big Bang happens. This is the singularity picture. To know what really happened, physicists need to subsume relativity into a quantum theory of gravity. To be logically consistent, there has to be a theory that sometimes unites quantum mechanics and general relativity. Loop quantum gravity, Lee Smolin, retained Einstein's theory but changes the procedure for implementing it into quantum mechanics. Revised string theory, this is the main topic I'm going to speak about. Revised string theory is a combination of general relativity and quantum theory. The elementary particle, this is the most important thing in string theory. The elementary particles are not point-like but rather infinitely thin one-dimensional objects like the string. The combination of string and T duality give rise to new possible cosmologies in which the universe, say 5 seconds before the Big Bang, expanded at the same pace as it did 5 seconds after the bang. But the rate of change of expansion was opposite at the two instants. If it was decelerating after the Big Bang, it was accelerating before. In short, the Big Bang may not have the origin of the universe but simply a violent transition from acceleration to deceleration. String theory has opened up new window through which we can study deep cosmological questions such as those relating to the origin of our universe. We can use the theory to study the earliest moment of time just after the Big Bang. General relativity really predicts that there was a first moment of time, but this conclusion ignores quantum physics. Recent loop quantum gravity calculations by Martin Bojewald of the Max Planck Institute for Gravitational Physics in Gom, Germany, indicate that the Big Bang is actually a big bounce. Before the bounce of the universe was rapidly contracting. Theorists are now hard at work developing prediction for the early universe that may be testable in future cosmological observation. Revised string theory is a combination of general relativity and quantum theory. The basic idea is that elementary particles are not point-like, again I'm repeating, but infinitely thin one-dimensional object, the string. The large zoo of elementary particles, each with its own characteristic property, reflects the many possible vibration pattern of a string. To understand the structure of space on the very smallest size scale, we must turn to quantum theory of gravity. Gravity is involved because Einstein's general theory of relativity reveals that gravity is caused by the warping of space and time. By carefully combining the fundamental principle of quantum mechanics and general relativity, physicists are led to the theory of loop quantum gravity. Quantum gravity predicts that space comes in discrete lumps, the smallest of which is about cubic Planck length or 10 raised to the power of 99 cubic centimeter. Time proceeds in discrete
10 raised to minus 9.
10 raised to minus 9.
Everywhere you have put plus.
Yeah, it should be minus. Because I'm more a philosophy student. Yeah. Time proceeds in discrete ticks about Planck time, and it is my pleasure that I'm presenting a paper in front of scholars. Now I've minus 40, yes. Now this is an attempt to compare between string theory and Jain theory. Now, the common factor is existence and permanence of the universe. Philosophers, theologians, and scientists have long debated whether time is eternal or finite. That is, whether the universe has already existed or whether it had definite genesis. Einstein's general theory of relativity implies finiteness. Expanding universe must have begun at the Big Bang. Yet, general relativity ceases to be valid in the vicinity of Bang because quantum mechanics comes into play. Today's leading candidate for a full quantum theory of gravity, string theory, introduces a minimal quantum of length as a new fundamental constant of nature, making the very concept of Bangian theory genesis untenable. Quantum strings have a finite size. Were it not for quantum effects, a violent string could be cut into half, again into half, and so on, finally becoming a massless point-like particle. Now, according to this Jain theory also believes in the existence and permanence of the universe. Shat Dravyatmak Lok, that is what the lok is. According to Jainism, universe consists of 6 substance. Asti means exist and Kai means body. So this is the common factor between a string theory and Jainism theory regarding the existence and permanence of the universe. Then what about the quantum state of the universe? Quantum state, according to string theory, the shape is like a funnel glass or hourglass. Visible universe, quantum states of space at a minuscule scale is 10 raised to the power of 85 cubic centimeter or 10 raised to 184. Am I right? 184 spin network. And 10 raised to 60 colors. And here colors are quarks, neutrons, and their interaction, chromodynamics. And according to Bhagavati Sutra, universe is 14 Raju or 343 cubic Raju, a type of linear astrophysical measurement. String, Raju and string, here also I am compared that it is almost sound similar. Now, existence of extra dimensional space. Quantum string demands the existence of extra dimension of space in addition to the usual 3. Yes, time is up. Electrons may be strings whose ends can move freely in 3 of the 10 spatial dimensions. So here again, Jainism and string theory, they talk about 10 dimension. Even Jainism speaks about 10 dimensions. And in Bhagavati Sutra, 44 and 45th Gathas, there was a conversation between Khandak Rishi and Mahavir regarding the nature of nature of the universe. Similarly, there was a paradoxical point of view given by Jamali as well as Lord Mahavir regarding what is the nature of universe according to Jainism. So, in a vague way, I've tried to compare with the string theory, modern string theory, and Jainism theory. Thank you.
Much. The session is now open for question answer round, and we request one question per speaker.
Okay, let us see if there are any
Yes.
questions. Of course. Yeah, Dr. Roy.
I want to Dr. Joshi. I like to inform you that a group of physicists in Princeton University, they are working on cyclic universe for last 1 decade. And Swami Vivekananda, long before, he cited Vedanta and saying that out of chaos, universe is being originated, and he used the term particularly chaos. And this Princeton group, they are using chaos in general within the frame of general relativity, and they are making the model for cyclic universe. And if you look Vishnu Puran in Indian philosophy as well as Jaina philosophy, there is concept of cyclic universe. So people can do in that direction, and it's very comprehensive and detailed analysis they are doing. And second one, the question to you that you are saying that according to Jaina philosophy, is absolute space of time, but then how do you fit spatial relativity within Jaina philosophy? How do you fit the concept of
Because spatial relativity talks about 4 dimensions, and dimension has no limit. So it's okay, verify what is the problem. Because even general theory or 5 dimension, 11 dimension, all dimension may be infinity, it is infinite. If all are infinite, linearly infinite, so it has no problem at all.
I mean, when the string theory was started to develop, then lot of excitement was generated regarding the epistemological issues. And then people told categorically that strings are like Sutratma in Bhagavad Gita. And that time, even the string theorists were discussing that Sutratma is present in everywhere. So strings are like Sutratma. And there is a concept of Big Bang in her lecture. So if Big Bang is there, unless you consider cyclic universe, how it is compatible with modern cosmology and Jaina philosophy?
Yeah, the cyclic universe has been extremely interesting concept, and Penrose and the Princeton group, and they have been trying to develop the theory. There have been some profound issues for both the cyclic, that is how to convert it into the Big Bang. That is the puzzle, as far as I understand, they were trying to work out. And the concept is by all means.
Again, very encouraging results are coming out.
Yes.
Maybe we Indians should jump into the field because it's,
That is what I was trying to emphasize, that we should go into a detailed and we have to go into nitty-gritty. And point to point comparison and in-depth analysis has to be carried out to bring out any meaningful results. Yes, any kind of convergence. Yeah, thank you.
All religions of this world, including Jainism, Buddhism, Vedic, Islamic and Christians, have described in their scriptures that earth is everywhere flat. Now what all the speakers let me say that where the earth is flat or spherical.
No, it is not flat, let me say on behalf of everybody. Okay, and we'll come to this. Dr. Jeevraj Jain has made a very important point. I'll come to that. But Earth is not flat. Let us take that for granted.
I have a question for
Yes.
I don't know why you quote Aristotle about something cannot come out of nothing. I mean, you can take philosophy, you can take Heidegger, you can take many other Western philosophers, even Aquinas. Whether something can come out of nothing is a paradox. It should be made as paradox. There is no clear answer to that. And it's very clear in the Buddhist tradition as well, which is why they veer towards was shunyata. True. But there are within the quantum theory as well, within Big Bang, people like quantum Smith and so on, who think that there was a state of nothing. That the universe was contracting or expanding and so on, their own speculation. Because people can't, in the West, seem to think the possibility of something from out of nothing. It's not in a state of nothing. I don't know how James would answer that question. I mean, time being infinite means to be that perhaps there was really nothing. So I think we should keep these things open from the it's not, you started with God, I simply said that it is God.
Yes, just let her answer.
Jainism doesn't speak about God, but it works naturally regarding universe. And it speaks that it is the universe was always there.
I see, the universe.
Yes, always.
Dr. Joshi, he was to touch upon galaxy and locus. I mean, if it's a brief thing, can you cover it up now in the question and answer session?
Galaxies are not mentioned in Jainism.
Galaxy, you want to mention about galaxy and locus.
Well, I was, you see, my whole purpose was to raise a few interesting questions. I was going to tell you that, the life is there on Earth, but in recent decades, last 10-15 years, now the new development has been that we have observed hundreds of systems, planetary systems around other stars, where the life has been observed actually. I mean, at least the planets have been observed.
Hey, life has not been observed.
Yeah, that's right. That's what I am trying to
Okay.
So you see, the planets have been observed, and if the planetary systems are observed, then there is a strong chance that there is a possibility of life. It may not have been observed, however, the very fact that we are seeing these planetary systems out there, what does that mean? So, I was just trying to allude to or raise a question that why not try to get some implications from these concepts of loka, and then can we take this prediction of or the observation of the planets out there and how to take that further? What further implications would be there? That's all for the moment.
Okay. Next, last question.
My question is for Rahul sir. As it is claimed in his lecture, the Vikarn, the Bodhayantar theorem, was intended to find dimension, especially two dimension. Actually, it was it is a very formal statement we found in India in Bodhayantar theorem. It was used in ancient cultures area, in other areas too. But I think it was intended to transformation of the areas to find a correct accuracy. So it needs justification if it is intended to be find a dimension.
Actually, he gave a formula, distance formula. And then further research, and they could find that this is just measuring the universe slowly, the four-dimensional line for distance formula, fifth dimension. So actually this is development of science. What is wrong in it? Because somebody will find something, and then on that somebody will find just PV equal to constant, world law. Then other people will find some other thing. So what is wrong? He has given that formula how to find this and that's all.
Okay.
Then he utilized that for measuring as meter state, as measuring state, and to do the whole universe. So from 1 dimension to 2 dimension, to 3 dimension, to 4 dimension, to 5 dimension, you can have 6 dimension, 5 dimension, some physical quantity which can has qualifications to be dimension you can apply. What is there? And then Euclidean and non-Euclidean geometry, you can use that. That's all.
Professor Bandari, to clarify this issue of flat versus round Earth using this very interesting cartography.
Yes, I am coming to that.
Yeah, please. Because you see, in the sort of
Yes.
of matter.
You see, okay, I'll just take 3-4 minutes to conclude, because I think, in my opinion, this has been the most exciting session. And we have covered we have covered everything, and our friend from IIT should have been given 1 hour to explain, because you see, most of us don't understand. He talked about everything. But I think one point we should remember is, all the speakers tried to bring out what are the problems and how we can draw upon our ancient wisdom to solve some of them. Because science is also it is not a converging thing. Different cosmologists talk about different models. They have not come to a conclusion. It is not something like, well-established theory, like special theory of relativity is well established. And so, origin of universe is not yet, that problem is not solved. And I personally think that we should involve all these experts. There is a lot of conceptual things in our scriptures of all Vedanta and Buddhism and so on. But one thing we have to be careful not to jump to the conclusion that it is said there and this is how it is. And I just want to say that just going paper by paper, that what Professor Joshi did is he brought out what are the problems in modern cosmology. That it is not a closed topic. There is a homogeneity problem, there is a Big Bang space-time problem, there is a quantum gravity not many people accept, so it is all open. And string theory is still not on very firm ground, so let us not jump to the conclusion that we can take upon a string theory and this is given in our scriptures. This is all open, and this is very good. This is the point where we should come in, because tomorrow I will talk about how we missed many things, so I will not cover that. And of course, Professor Raval told about the fifth dimension is mass, but again, people can contest that. It has to be established. You see, giving an idea is one thing, and proving it is entirely different thing. And then the acceptance by the world is entirely, a different ballpark. So, I think, some people say some other thing is in fifth dimension, and Kaluza theory and Klein and this and that, and of course Professor Raval has come up, and our friend from IIT, he has actually covered everything. My suggestion to you is, take one topic and talk about that. You can't cover the whole universe and everything in just 7 minutes. I am very sorry that we could not give you much time. What take-home message is that this is a subject ripe for discussion by our Jaina scholars, by acharyas, by other faiths. The Vedanta, there's a lot of things talked about in Hinduism and Buddhism and Shunyavad and whatnot. And I don't know, but I hope one of the things after this conference is we'll sit together and involve all these people. And there are, I'm personally convinced, I cannot express it here, that there are some conceptual ideas which are very important, and we can use them with our advantage to understand the origin. So this is all I would like to say. Thank you very much. But 1 minute, we have to give some memento, right? Dr. Jivraj, actually this is coming to that point of flat earth. Okay? And this is very important. I hope that after this talk, nobody should go home and believe that the earth is flat. Let us be very sure. When I was struggling to understand, you see, if any one thing is wrong, then you say all these scriptures are wrong, because you lose faith. And this geography of the earth, the geography of the universe has been a very controversial subject, and now it is open to scholars. So I don't care about Mithyatva and all that, what you mentioned. But he is the one who proposed. You see, Mahavir Swami never made any figures. I wish he was there to draw some diagrams. And problem with us is that with one universe or one planet Earth or one type of life, you cannot make a theory. You need at least 2, 3. If we can discover some multiverses, or we have some idea, or if we discover another on Mars some life, or on exoplanets, I think we can, if we have 2 or 3, we can certainly, I think theoretical tools are so strong that we can make models which are realistic. But with one observation, in one point you cannot draw a line. Of course, some cosmologists do that. So, what the point I want to make is, he showed us that these diagrams are not physical diagrams. They are not physical diagrams. How do you express something on a sheet of paper which is two-dimensional? Why do you call it bhugol? I want to ask my friends. It itself says that Bhumi is goal. Okay, now why in geography is translated as bhugol in Hindi or in Sanskrit? It is goal. Okay, that let us, and he showed that these diagrams are not physical diagrams or maps where the rivers are flowing east-west and mountains are in equidistant and all are same heights. And this is just way of depiction. And we have tried